Hey everybody, welcome to our last lesson in chapter one, which is called direct variation. Direct variation is going to have a lot of terms, and don't get overwhelmed by them because it really goes back to a lot of things we've done in dealing with proportional relationships already. So, really, your goal today is you can explain direct variation and constant of proportionality. You already kind of know what these things are, so I think once you hear it again, it's going to make more sense. So, pause the video, jot down what's on the board, and we're going to talk about all these terms and really get into it. So the first term we have is this term called direct variation. What direct variation is, it's a linear relationship where x to y is a constant. So what do we mean by that? Well, let's take a look. A linear relationship. Linear relationship just means a straight line. So we talk about a line just like this one here that's nice and straight, where x to y is constant. So the idea is when we compare x to y, we do that, and what we get there is really kind of our two elements that we talk about. So direct variation sounds really similar to this concept of a proportion. Right? And why does it sound similar to a proportion? Well, what are the things we need for a proportion? One, we need a straight line. Sound familiar, right? Linear relationship, straight line. The other thing we need is we need it to start at 0, 0. So start at the origin. A constant always will start at the origin, right? Constants, as we think about that, it's going to be really easy to predict. So that said, direct variation is really another term to talk about something being proportional, to be proportional. That said, we go to this concept of a constant of proportionality. Constant proportionality is the ratio that's created in direct variation. Again, what we're talking about things are ratio. We know what a ratio is. Ratio is y over x, right? Whatever it might be over something else, a over b. We know ratios are written in that form, and it's what's created when we have this direct variation. So what is our constant of proportionality? Our constant of proportionality is really similar to slope. It's going to be how much are we running and rising when we're dealing with direct variation. So let's think about what this looks like in terms of a graph, if I were to graph this concept. So I'm going to keep my one quadrant graph that I've been doing. And what we get is, let's say on the bottom we're going to talk about time. On the side we're going to talk about distance or miles traveled. So let's go 1, 2. Actually, I'm going to switch this one. I'm going to go 2, 4, 6. And I'm going to go 1, 2, 3. So here we have something that's expressing direct variation, right? It's a straight line that's starting in the origin. The constant of proportionality is going to be what is my slope? How much am I going up, in this case 2, and how much am I going over, in this case 1? So as we think about this, as we think about constant of proportionality and direct variation, we really go back to some terms we already know. Now, where it kind of changes is how sometimes it's written. As we think about constant of proportionality, we get these equations. So there's an equation called y equals kx. And this equation is going to allow us to plug in values if we know how many miles we've gone or we know how much time and predict the other value. And it's how it works off each other. K is our constant of proportionality. So in this case, my constant of proportionality in this example is 2, right? Or 2 over 1. I'm going up 2 over 1. So using this equation, y equals 2, because it's my constant, x, I can plug in numbers to find values. Let's give it a shot. Let's say I want to know in 3 hours, how far will I have gone? Well, y is what my distance is, my miles, equals 2 times x, which we said was 3 minutes. So it's going to be 6, because 2 times 3 equals 6. This concept really gets covered heavier in 8th grade math as we get to it, but it builds off this concept we're learning here.